Here we have a SAT math question. There is a system of equations given over here. In the given system of equations, A is a positive constant. The system has exactly one distinct real solution. What is the value of A? Okay, so the given system has only one solution according to the question. That means the graph of the first equation, graph of the second equation will intersect at only one point because the system has only one real solution. So usually the graph of the first one is an horizontal line, so that is y equals to negative 1.5, and the graph of the second one is a parabola, that is a vertically upward parabola. So horizontal line y equals to 1.5, and this is the second one is a vertically upward parabola, and they intersect over here at only one point according to the question over here. Okay, so we have to find the value of A. Okay, let's, in case if I want to find the point of intersection of the graphs of the given two equations, what I need to do is I have to solve the given system. So for that, I have to solve the two equations over here. So for that, let me write the first equation, that is y is equal to negative 1.5 as it is. Okay, now I consider the second equation, that is y equals to x square positive 8x positive A. That is, we have some stuff which is equivalent to y. So now what I can do is I can plug in this stuff x square positive 8x positive A for this y. So because we are solving this system to find the point of intersection of the two graphs, okay, now we can plug in this expression for the y over here because this expression is equivalent to y. Then we get x square positive 8x positive A equals to negative 1.5. Okay, now I have a quadratic equation in the variable x, but it's not in standard form. Standard form means we must have everything on the left side, and on the right side we must have 0, but here we don't have 0, we have negative 1.5. So to make this negative 1.5 as 0 on the right side, I have to add 1.5 to both sides so that I'll be able to get rid of this one. Okay, now let me add 1.5 to both sides. When I do so, this negative 1.5, positive 1.5 will cancel out. I'm getting x square positive 8x positive A positive 1.5 equals to 0. Okay, now this quadratic equation over here is in standard form, that is ax square positive bx positive c equals to 0. Okay, so here A is a quotient of x square. What is the quotient of x square in our equation? So we don't find any number in front of x square over here, so I have to assume there is 1. So we get A equals to 1. So B is the quotient of x. Here, the place of B we have 8, so B is equal to 8. And C is a constant term. At the place of C, we have A positive 1.5. Okay, so here I have a quadratic equation. When I solve the given system of equations, I get a quadratic equation. 1 second, let me mark it. So when I try to solve the given system of equations, I am getting a quadratic equation over here. So whenever I have a quadratic equation, there are three possible situations. One is, so the quadratic equation may have two real solutions, or the quadratic equation may have only one real solution, or the quadratic equation may not have real solution. Okay, so how do we have to know? So whether the quadratic equation has two real solutions, or one real solution, or no real solution. So for that, let's consider the quadratic equation over here. There is ax square positive bx positive c equals to 0 here. In this quadratic equation, let's find the value of the discriminant b square negative 4ac. So the expression that I've written over here in terms of A, B, and C is called discriminant of the quadratic equation because it discriminates the nature of the roots of a quadratic equation. That is, the value of this expression will tell us how many real solutions a quadratic equation has. If the value of b square negative 4ac is greater than 0, then we'll have two real solutions for the quadratic equation. If the value of b square negative 4ac is equal to 0, then we'll have only one real solution for the quadratic equation. If the value of b square negative 4ac is less than 0, then no real solution for the quadratic equation. Okay, according to the information we have, so the given system has exactly one solution. So that means if I solve this quadratic equation over here, because I got this quadratic equation by solving the given system. Since the system has only one real solution, so if I solve this quadratic equation, I'll be getting only one real solution. Okay, so if I get only one real solution, so which of the three possible cases to be considered? I have to consider the middle case, that is b square into 4a is equals to 0. Because if the value of the discriminant equals to 0, then we have only one real solution. Okay, now let me take this case over here, that is b square negative 4ac equals to 0. And already we got the values of a, b, and c over here from the quadratic equation here. So the value of b is 8, that means 8 square negative 4 times. The value of a is 1, the value of c is a positive 1.5 equals to 0. 8 square is 64, negative 4 times 1 is 4 times a positive 1.5 equals to 0. Okay, 64, we can distribute this negative 4 to a, then I'm getting negative 4a. When I distribute this negative 4 to 1.5, I am getting negative 6 equals to 0. Okay, now negative 4a, when I combine this 64 and negative 6, I am getting positive 58. Okay, let me write the equation over here. Negative 4a positive, sorry, negative positive 4a positive 58 equals to 0. Let me write the equation over here. Negative 4a positive 58 equals to 0. So now let me subtract 58 from both sides. When I do so, this positive 58, negative 58 will cancel out. I am getting negative 4a equals to negative 58. So now I divide both sides by negative 4. When I do so, this negative 4 will cancel out. Okay, let me write the solution over here. And negative will cancel out. And 2 goes into 4 twice. 2 goes into 58, 29. So I am getting a equals to 29 over 2. So I have solved for a. The value of a is 29 over 2.